So this is the lesson for 2-1 Inductive Reasoning and Conjectures. So we're going to start off talking about what induction reasoning is, and that is the reasoning that uses a number of specific examples to arrive at a broad generalization or conclusion. So we do this a lot. Basically everything we do is some sort of inductive reasoning and kind of processing in our brain. So it's specific examples to arrive at a broad generalization or conclusion. Conclusions arrived at by inductive reasoning lack the logical certainty of those arrived at by deductive reasoning. So deductive, we have a little more proof than inductive. So conjecture is an opinion or conclusion formed on the basis of incomplete information. Okay, so for our first example, we're going to write a conjecture that describes the pattern 2, 4, 12, 48, 2, 40, then use your conjecture to find the next item in the pattern. So it looks like to get from 2 to 4, it looks like we're maybe doing some sort of multiplication, multiplying 2, maybe times 2 to get 4, and then 4 times 3 to get 12, and then 12 times 4 to get 48. So multiply by that next number up. So I'm going to go ahead and write that out. It looks like multiplied by 2, 3, 4, and 5. So the next number will be multiplied by 6. So 6 times 240 is going to equal 1,440 as our next answer. So next we have this pattern, 3, 9, 18. So how are we getting from that first one to the next one? So it looks like add 6, add 9. So what would we add next? We would add 12. So we would be at 30 for the number, and then it looks like we would have our triangle. Make kind of a triangle. Oop. Kind of a bigger one here. And then we're going to have, looks like we have 1, 2 lines, so we're going to end up having 3. 1, and then 2, and then 3. And then we kind of split it into those little triangles. So that would go there, that would go there, that would go, whoop. Make that one a little prettier. And then this would go here. Could kind of do it like that. There we go. So that would be the next one in the pattern. So this pattern, it looks like we're going from 1 in the top, so we're going to continue that 1. I guess it doesn't equals, but our next one is going to be a 1 in the top, and then it looks like we're going from 4, 9, 16, 25. Those are perfect squares. So our next one, if this is 5 squared, would be 6 squared, so that'd be 36. And then this one has our 1 at the bottom, so that's kind of the pattern it looks like. All right, so make a conjecture about the sum of an odd number and an even number. So let's go ahead and add 1 odd, 1 even, that's 3, 1 odd, 1 even, 1 odd, 1 even, 1 odd, 1 even, and let's look at that. Looks like the sum of an odd and an even number is odd because all of these are odd. So I'm going to say the sum of an odd number and an even number is odd, is our conjecture. And there's our examples up above to support that. All right, so the table shows the total sales for the first 3 months a store is open. The owner wants to predict the sales for the 4th month, make a conjecture about that 4th month sales. So 500, 1500, and then 4500. Well, it looks like from 500 to 1500, that's tripling, and then another 1500 to 4500, that's tripling as well. So the sales triple each month. So in the 4th month, there will be 4,500 times 3, or 13,500 in sales, if we make a conjecture with that same pattern. All right, so let's take a look next at counter examples, and that's an example used to show that a given statement is not always true. So if we can find an example that doesn't fit that, then we kind of are proving that that's false. So let's go ahead and plug in an example here. Real numbers, so that could be negative, positive, fraction. So I'm going to go ahead and plug in a negative. Negative 1 squared is 1. 1 is still greater than negative 1. So negatives don't work. We know positives don't work. So let's go ahead and try a fraction. Let's try a half squared. Is that greater than 1/2? Well, 1/2 squared is a 4th, and 1/4 is not greater than a half. So that would be considered a counter example. JK is equal to KL, then KL is the midpoint. Well, is there a way to make these equal without it being in the middle? If we made them separate segments, JK, still congruent or equal to KL, but now it's not in the middle because it's not one segment. So there we go. This one's supposed to be n to the 3rd, not n with a 3. So if we did an integer, integers are negatives and positives. Let's go ahead and try a negative. Negative 1 cubed is equal to negative 1, and that's not positive, so there's a counter example. 2 complementary angles are not congruent. Well, we could definitely come up with 2. 40 and 50 are 2 angles that add up to 90, but they're not congruent or the same. And then this last example here, based on the table showing unemployment rates for various countries in Texas, find a counterexample for the following statement. The unemployment rate is highest in cities with most people. Well, let's take a look where there's a lot of people. It looks like there, and even Maverick. Well, if we look, Maverick has a very high rate, but it doesn't have as much, as many people as El Paso. So let's go ahead and make kind of a comment about that. Maverick has only 50,436 people in its population. And it has a higher rate of unemployment than El Paso, which has 713,126 people. So don't forget to answer those think and discuss questions and the ones off to the side to expand your thinking.